Okay, so the screen is visible. Okay, you need not write the attendance in the chat box because I will be taking the attendance manually after the class. Okay, I'm taking the attendance manually after the class. We need not write the attendance in the chat box. The slide is visible. Yes.
Yes,
Okay.
sir.
Okay, so let's start our class. So what we're talking about, we'll be talking about the simulation of DC distributor by network analyzer. Okay. Now, as we know that when we're talking about this distribution system, there actually we can think about it in this way that let me that there are three portions. No, one is our distributor, one is our feeder, okay, and one is our serviceman. So I think this particular figure, let it come. Yes. So this particular figure I think is very common for everybody of us. That this is the substation, okay, and this is the feeder that we have, and this is the distributors from where the tappings are taken, okay, and what we have then, and this is this is the tappings that we're taking from the distributor. This is the feeder, okay, and this is the distributor from which we are taking tappings, and these tappings are the servicemen. Okay, so as you can see that this is the typical distribution system, and how can we differentiate? Can anybody tell me how can we differentiate between a feeder and a distributor?
Sir, in feeder, we cannot find any tapping.
Okay.
Distributor, we can find tapping.
Okay, but that's a very basic idea. But rather, when we're talking about how can we differentiate between the feeder and the distributor, obviously we have to talk about something about its design parameter. No, so obviously what we can understand that since, as you said, that since we do not have any tappings of the feeder, so obviously the size of the feeder is determined primarily from the current carrying capacity of the feeder. Okay, how much current is flowing through the feeder, that determines the size of the feeder. And because of this, what we say that the voltage drop along the feeder is said to be more or less the same. Okay, the voltage drop along the feeder is taken to be more or less the same. But what about a distributor? As we know that, as you can see from this particular figure, that what we have means distributors have tappings on them. So basically the main basis of design in the case of a distributor is the permissible voltage drop along the distributor. Okay, the permissible voltage drop along the distributor. And after that, obviously we have the servicemen, which is actually connecting the distributors to our homes. Okay, those are known as our servicemen. Okay, I hope this is clear. Now what we'll be doing is this experiment. As you can see, the name of the experiment is simulation of DC distributor by network analyzer. Now why we are going for a network analyzer? We are going for a network analyzer because it's not possible to have a huge distribution system in our simple small lab. So what we do is that we try to make or simulate this 400 volt DC supply using a simple network analyzer, which is nothing but a connection of resistances. What is the figure, or what is the this is the how the DC network analyzer looks like. So as you can see, this is just a simple box where you're having resistance values, and we'll be connecting the wires in such a way so that we can simulate a typical distribution system. Okay, because our simple distribution system will be means if we are going for a practical one, it will be a very large size, so there's no point of doing that. So what we are doing is that we are converting it to a very small size in our laboratory by using this network analyzer. We'll be talking about the network analyzer again when we're talking about our three-phase fault networks in our fourth year labs. Okay, we were talking about this network analyzer again. This one advantage of using this network analyzer is, see, uh, what we know that from the design perspective, that if we have used an inductor, no, because a distribution line or transmission line, whatever we are taking, that gives us impedance, that is Z equal to R plus JX. Okay, but as we know that if we use means what is the frequency here would be using, so obviously that frequency would be 50 hertz, so the size of the inductor would be very high. So we'll be using many such, if we are using many such impedance values, so you can very well imagine that the means if we have so much of impedance values, then so much of means as many as those inductors will be there. So the size of the inductors will be very large. So simple 10 inductors will be taking will be occupying a huge space. Okay, so there's no point of going for those. So what we try to do is that we to scale it down through our this network analyzer. Okay, now what is our experiment purpose? So as I hope that everybody has got the instruction sheet. Yes, everybody has the instruction sheet with them. Okay, so
Yes.
there what we can find the objective. Okay, what is the objective of this particular experiment? As you can see that the objective is to that we have a AC two-wire distributor with following loads is supplied by from a 400 volt DC supply. Okay, so what we are doing is to verify the calculation one potentials at each node point. Means at every tappings we'll be finding out the voltages, voltage drops, what is happening. Okay, and we'll be finding out the current flow in each section of the distributor. When the distributor is fed at single end, obviously one end, then it is a ring main connection, that is distributor is connected as a ring, and the third as an interconnector. An interconnector of 0.5 ohms uh, resistance is connected between the minimum potential point and the feeding point. Okay, that is our objective. Now if you have your instruction sheet, then please forget the figure that has been given there, where we have the current ratings, all the current ratings are given, no 20 volts, 40 volts, like that. Okay, please forget that and use this ratings. Okay, this simulated circuit diagram of the DC distributor will be using for our purpose. Okay, this simulated circuit diagram, as you can see, the voltage has been scaled down from 400 to 20 volts, the resistance of from is 100 ohms to around as you can see 0.01. Okay, then we have the current scale also, so it would be 2000 milliamperes. Okay, so like this way we can actually scale down the current. Okay, so what we are trying to do is that we will be trying to simulate this three single end feeding, both end feeding, and both end feeding with interconnector in our simple that network analyzer. And in the process, what we'll be doing in the process, we'll be finding out these current values. I hope it is visible. Okay, I'm just making it large. Everything is very slow today. I hope you can see it. Okay. So what are the readings that we're taking? We'll be taking, yes. So we'll be taking our VPA, the single end feeding, VPA, VPB, VPC, VPD, and similarly IPA, IAB, IAC, and so on. Okay. Similarly, we'll be taking the same readings for our both end feeding also and both end feeding with an interconnector. Now, obviously, why an interconnector is used, we'll be seeing it later. I'll be talking about it later in the class. Okay. So whenever if you had performed this experiment in the lab, so what you have to do, so there would be a top sheet. In the top sheet you have to write the name of your friends and so on. In the next page you have to write the title. Okay, so title and the objective. So what is the title of this experiment? So the title of the experiment is simulation of DC distributor by network analyzer. Okay, and the second line of you have to write the objective. So this is the objective of this particular experiment, and third line you have to draw the circuit diagram. So this is the circuit diagram. Okay, and after the circuit diagram you have to write down your uh, apparatus list. Okay, so this is the apparatus list. I have forgot to write down the range and rating and the megas number, but please remember, so this is the table for apparatus list. This table you will be following for your up to your fourth year second semester. Okay, so please remember this table. So first of all we're talking about the serial number, then the item, the quantity, then the range of rating, then the maker's name, and then the maker's number. Okay, I forgotten to write the range of rating and the maker's number, so please excuse me for that. I hope you can understand that how the apparatus list can be written. Okay, so what we'll be using here, we'll be using in this for experiment a digital voltmeter, a digital ammeter, a regulator power supply, and a trainer kit. Means that network analyzer that we have, that is known as our trainer kit. Okay, so let us see the videos then. So this is the typical figure. So here the power supply is given across this volt. See, V is written, and these are the points. Means these are the points. Means these points. Okay, we will be simulating these points here in this particular network analyzer. Okay, now what we're doing, we'll be seeing the videos. Okay, so to see the videos, what you have to do is that I have to stop the presentation. I have to I have to open the tab for um, other things. Okay, tab 4 means I have to open my G drive where all these things are given actually. Okay, so let us see that one. So let me stop this presentation and open the tab presentation where we can see our the lab experiments. Okay. Yes, it is visible now. The G drive is visible.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. So let us see the videos then one by one. So first of all, we're talking about our single feeding. Okay. So let us see the videos. One. Somebody is trying to enter. Let me. We are first doing the single and feeding. As you can see, we are supplying 20 volts into the network. তারটা একবার দেখিয়ে দিন, তারটা একবার তুলে দেখিয়ে দিন, তারটা তুলে, তার ওয়্যারটা হ্যাঁ। Yes, this is the supply that is coming to the AC network analyzer. Now we will be measuring the voltage at point VPA. This is the voltage drop for VPA. Okay. As you can see that we are measuring the voltage drop for VPA. See, the voltage has dropped. Now we will be changing for VPB. See how the voltage is dropping as we are going forward along the DC distributor. Yes, next. VPC, here also see how the voltage drop is taking place. See, now the voltage has dropped from, now this is the voltage drop for VPQ. Okay, the voltage drop for VPQ. Okay, now we will be measuring the current. Yes, this is the terminus of the multiplier. First of all, we are measuring IPA. See how the terminal has been changed by this switch. Then we'll be measuring IAB. Yes, IAB. See, now we'll be measuring the IAB. Okay. Next, we'll be measuring IBC. Now we are measuring IEQ, as you can see here. Okay, IEQ, and see the change in current. The current would be 0. Okay, I hope the first video is clear. Yes. Hello.
লাস্টেরটা বোঝা গেল না।
লাস্টেরটা বোঝা গেল না? লাস্টেরটা যদি তোমার কাছে ছবিটা আছে ডিসি ডিস্ট্রিবিউটরের যে ছবিটা, ওকে, সেখানে আমরা যদি আবার ছবিটা দেখি, আমাকে তাহলে আবার প্রেজেন্টেশনটা ব্যাক করতে হবে। আগে আমি ভিডিওগুলো দেখে নিচ্ছি, তারপর যে কোয়েশ্চেনগুলো আছে সেগুলো লিখে রাখো, পরে সেগুলো আমি ক্লিয়ার করছি। ওকে, ঠিক আছে? কারণ
Okay,
আমাকে আবার না তো ব্যাক এন্ড ফোর্থ যেতে হবে, সেটা করলে ইট উইল বি ভেরি ডিফিকাল্ট। ওকে, সো এবার কি করছি আমরা, এবার আমরা বোথ এন্ড ফিডিং করছি। আমরা একটু ছবিটা আমরা এবার কি করব, বোথ এন্ড ফিডিং করব। মানে আমরা পি আর কিউ দু সাইড দিয়ে কিন্তু 20 ভোল্টস আমরা ফিডিং করছি। তাহলে অবভিয়াসলি কি হবে, হোয়াট উইল হ্যাপেন, সো দেয়ার হ্যাজ টু বি আ পয়েন্ট ওয়্যার দ্য কারেন্ট ডিরেকশন উড বি চেঞ্জিং, কারেক্ট? আমরা যদি পি থেকে মেজার করতে করতে যাই, তাহলে একটা পয়েন্ট আসবে, একটা ট্যাপিং এর পর কি হবে, যে কারেন্ট ডিরেকশনটা রিভার্স হবে, তাই তো? কি, this is the theory? So
Yes, sir.
what we should be seeing, that the current direction is is coming out to be negative. Okay, let us see that one now. We are talking about now both and feeding. As you can see now, this is the PQ has been shorted here to measure, means to simulate both and feeding. Now in the PQ distributor, now we are using both and feeding, and we will be measuring the same things like we have done previously. Okay, so we are starting with both and feeding, as you can see, or both and feeding. Okay, let's start. So first of all, we are measuring the voltages, that is VPA. Okay, we are measuring VPA. Then we are measuring VPB. Okay, then we are measuring VPC. Then we are measuring VPD. VPE. And VPQ. We'll be measuring the currents now. IPA, IAB, then we'll be measuring IBC, then we'll be measuring ICD, see there is a change of sign in the multimeter. It is indicating that at this position current is flowing from the other side. That is current is flowing from the Q side also. Okay, I just want to clarify one thing. That is not the multimeter. Okay, that is the ammeter only. Okay, that is not a multimeter, but that is a ammeter only. Okay, let us continue. Yes, we will continuing with IDE. See how the current value is decreasing. Then we'll measure with IEQ. So as you can see, there is a change of sign, so it indicates that there is a change in the supply. So basically, key P and Q are connected by the same potential. So current is flowing into this uh, DC network from both sides. That is from both P and Q. Okay, now what we'll be seeing? We'll be seeing now our both end with interconnector. Okay, both end feeding with interconnector. Now, why will we using an interconnector? Can anybody tell me? Why we use an interconnector? Okay, just think about the answer. We'll be seeing it just now. Okay, now what the let us will feel seeing both end feeding with interconnector. Okay. Now in the third run, we'll be talking about our both end feeding with an interconnector. So as you see from your circuit diagram, that now P and C is connected. So here you can see that P and C is connected. Okay, P and C is connected. Okay, P and C is connected. Okay, so why P and C is connected? I hope you can understand, because in the previous experiment, in the previous or the second part for both end feeding, we found out that after C the current direction is changing. So obviously point C is our minimum potential point. Okay. Okay. In the third one also we'll be measuring the voltages first. So VPA, then we'll be measuring VPB.
Sir, could you mute your mic because of
Okay.
that echo is
Okay,
there.
okay.
C.
Measuring VPD. We will be measuring VPE. And we measuring VPQ. Now we'll be measuring the currents for both end feeding with an interconnector. First IPA, next IAB, then we're measuring IBC, next ICD, next IDE, next IEQ, and last IPC. I hope everybody, I'm stopping the presentation. I hope I hope you can understand. Now let us talk about what your problem was. Yes, somebody was saying that you cannot understand what we are doing. Which portion you couldn't understand? Just tell me.
না স্যার তখন অ্যাকচুয়ালি কারেন্টে কিভাবে মেজার করেছে তো বুঝতে পারিনি, তারপরে ভিডিওগুলো দেখাবো বুঝে গেছে।
ওকে ওকে, ঠিক আছে। এবার স্লাইডটা দেখা যাচ্ছে তো? স্লাইডটা ইজ ভিজিবল না? ওকে, so now what we are seeing, so these are the results that we have got. Okay, after performing this experiment, this is the results we have got. This is for our single in feeding. As you can see, we have VPQ. So obviously what will happen, that since the supply is at one end only, as we go to the far end of that distributor, the current value would be decreasing. Okay, so as you can see that the current value will be decreasing here. As you can see that the current value is decreasing. Okay, so here the scale factor, everything has been done for your purpose. Okay, and then what we do is that we'll be doing the same thing for our both end feeding also. So both end feeding করব, তার মানে কি একটা ট্যাব আমরা বলছিলাম যে আমরা দেখলাম কি সি এর পরে যখন আই সিডি নিলাম তখন কারেন্ট ডিরেকশনটা চেঞ্জ হয়ে গেছিল, মানে কারেন্ট ডিরেকশন চেঞ্জ হয়েছিল মানে কি একটা নেগেটিভ সাইন আসছিল, তাই তো? তার মানে দিস পয়েন্ট সি is our minimum potential point. Let us see that one also. So we measure these values also, VP and so on. Okay, so this is C, the current direction is changing from C. Okay, see the current direction. So we can very well imagine that since now the current is being fed from both end. Okay, so we can find out that C is the minimum potential point. I have done one thing for you also. Okay, so how C is point is obviously the minimum potential point, the calculation is also shown. So here the is coming out by calculation is coming out to be around 370.203. Okay, and here also as you can see that it is coming out to be around like that value only. Okay, 370. Okay, the actual voltage at the terminal C, it is coming out to be C 370 by and if we do it through the calculation method, then we are also getting that 370.203. Now what is happening, now again we are using both end feeding. So here also we are finding both end feeding. So we are connected an interconnector between the minimum potential point and the feeding point P of 0.5 ohm resistance. So here also we are finding out the same things, and we are finding out what. So yes, the answer of that question is what, that why we are using interconnector, because if we connect an interconnector between the minimum potential point and the supply point, then it will improve the voltage drop in the corresponding sections. Okay, that is the voltage drop in each of the sections would be, in each of the terminal points would be improved. Let us see that one. So here also in this both end feeding with interconnector also we'll be finding out, we'll be measuring the current also. Here also we are seeing that point C is the minimum potential point, and we are seeing these values. And what we'll be seeing is that so how we'll be finding out the both end feeding with interconnector. So this is the method that we should be finding that what is the current flowing through the both end feeding with interconnector. So by, as you can see, by this applying Thevenin's theorem across PC, we can find out this expression. But from this expression what we can see is that there is a huge difference coming between the IPC that is calculated and that is measured. Okay, that is measured. This is the IPC measured is this is this minus 33.68, and whereas calculated is coming out to be around 22.03. So we can very well imagine that there are tremendous amount of losses in this particular network analyzers. Obviously there would be losses because we have not considered the contact resistances, we have not considered the drop in the resistance of those wires. Okay, we have not considered all those things. So if we take into account all those things also, then what we can have is that we'll be having a both end feeding with interconnector. Okay, means the voltage drop would be improved. So let us see. So let us see this comparison. As you can see, that comparison of voltages in the three systems having single end feeding, both end feeding, and both end feeding with interconnector. You can see that with the presence of the interconnector, what is happening? That the voltage at those terminal points A, B, C, D, and E and Q, the means the voltage is improved compared to our both and feeding. Okay. Yes. Understood? Any questions till now?
No, sir.
Okay. Now তোমাদের করণীয় কি? What you have to do? You have to do is that what we have found out the values, okay, here. So you have to solve these particular expressions by yourself. Okay, you have to solve these particular expressions by yourself using the current values that is being given to you, and find out the percentage difference between between the measured and the calculated values. Okay, you have to find out the percentage difference between the measured and the calculated values for both, for all this single end both and feeding with interconnector, and send the scanned copy to me. Okay, and send the scanned copy to me. Understood কি বললাম? আমরা এখানে একটা ক্যালকুলেশন যেমন করে দেওয়া আছে, মানে ভিপিটা জানো তোমরা 400 ভোল্ট, সেখান থেকে তোমরা আইপি এটা মেজার্ড তোমরা করে করসপন্ডিং ভিসি ভ্যালুটা পাচ্ছ, কিন্তু মেজার্ড করছো ভিসি তোমার কত 370, তাই তো? তাহলে তোমাকে এবার কি করতে হবে, এটার মধ্যে কত পার্সেন্টেজ এরর হচ্ছে সেটা তোমাকে বার করতে হবে। This has to be done for all the three cases, that is for single end feeding, both end feeding, and with both end feeding with interconnector. ঠিক আছে?
স্যার তিনটে কেসে শুধু ভিসির ওটাই বের করব?
শুধু ভিসি না প্রত্যেকটা টার্মিনালে, আমি জাস্ট ফর এক্সাম্পল আই হ্যাভ শোন ইউ only for ভিসি। ওকে, জাস্ট ফর এক্সাম্পল আমি শুধু ভিসিটা করে দেখিয়েছি। ওকে, যেটা মিনিমাম পোটেনশিয়াল পয়েন্ট কিভাবে ক্যালকুলেট করছে, কিন্তু তোমাদের দায়িত্ব হচ্ছে সবকটার জন্য করা, ইউজিং দ্য কারেন্ট ভ্যালুস দ্যাট উই হ্যাভ গট। ঠিক আছে, যে কারেন্ট ভ্যালু পাচ্ছি সেটাকে নিয়ে তোমার কাজ করতে হবে। আন্ডারস্টুড?
ওকে স্যার।
ওকে, সেটা করে স্ক্যান কপি করে আমাকে এক সপ্তাহ মধ্যে পাঠিয়ে দাও। ঠিক আছে, যত তাড়াতাড়ি সম্ভব তত পাঠাও। সাবজেক্ট নেম দেবে কি? সাবজেক্ট নেম দেবে সেকশন বি, আর এই এক্সপেরিমেন্টের নামটা দেবে। ঠিক আছে,
সেকশন এ আমাদের,
ও সরি সেকশন এ আর সিমুলেশন অফ ডিসি ডিস্ট্রিবিউটর। ওকে
স্যার এই নোটগুলো কি তাহলে দিয়ে দেবেন,
আমি
মানে এই দুটোগুলো?
হ্যাঁ আমি এক্ষুনি
এটা
মেল
কি?
করে দিচ্ছি। রেকর্ডিংটা
আচ্ছা।
আসলে আমার কাছে আসলে আমি রেকর্ডিংটা উইথ দিস নোটস আই উইল বি ফরওয়ার্ডিং ইট টু ইউ। ওকে
স্যার
Any
ওখানে
question?
স্যার ওই পিকচার মানে ওই রেজিস্ট্যান্সের যে ফিডার গুলো যে পিকচার গুলো একটু দেখিয়েছেন, ওখানে ই গুলো কি মানে 10 রেজিস্ট্যান্সের ওখানে?
হ্যাঁ ওটা অ্যাকচুয়ালি রেজিস্ট্যান্স ভ্যালুস। ওমটা করছো, এই যে দেখো 100 ohms রিপ্রেজেন্টস 1 ohm অ্যাকচুয়ালি। ওকে, আচ্ছা ওটা মানে ওটা না লিখে এটা ই লেখা হয়ে গেছে, মানে এটা আমরা তো করিনি না, অন্যজনরা করেছে, সেটা
এটা স্যার
করে যারা
ওহম?
করেছে। হ্যাঁ ওম।
আচ্ছা আচ্ছা স্যার,
ওকে ঠিক আছে।
ঠিক আছে স্যার।
Okay, just let me stop the presentation, and please I will be taking the attendance